students, and welcome to this 28th edition of our Numerical Method 2 class. First of all, I would like to apologize. I promised that I will post a catch-up session of our class we were supposed to have on Wednesday. But unfortunately, I didn't do that, but it's not a problem. So that session will take place now, and later on, when I say later on, maybe over the weekend or somewhere there, I'll make an extra recording, right? So this being said, I gave you a homework where I asked you to look at, I asked you to generate these entries. Let us go back to the slide. This one, if you recall, no. This table, I asked you to go back and try to generate the entire table. Have you done that? Okay, if somebody did it, please indicate. I asked you to make sure that you obtain this table. The first one, this one, is already here. Is this? You can see the computation of this, and the second one is this one. Each time you just have H, and then you get the first column. So this first column, as I indicated last time, is through this formula. You just have, and then the number of function evaluation will be increased. Then you get, once you have generated the first column, the remaining column are obtained using this formula, which is in fact this one. Beta estimate is equal to more accurate 1 by 2 to the n, where n is the degree of precision of the, not degree of precision, order of accuracy of the method, minus 1. And then the more accurate, that is this one, minus less accurate. That's what will give you the remaining columns. Right. So you take this one, the first in the first column. So the first two entries in the first column will give you this, and the remaining, these two, this one, the second and the third will give you this, and then the third and the last will give you this. So it's similar to this table. You look at this. Oh, similar to this. It's similar. So in other words, it's like this. And then you take these two. And then you take these two for that, these two for that, and then this and that for this one, this and this for that. And finally, you take this one and this one, those two. So that's how you compute. But here, you use the composite trapezoidal rule for the first column. Now the remaining column, all the entries from the second, third, fourth, and so on, you use the entries to the left, right? The entry on the left, this one. So if I want to compute the current entry, I use the previous column, the one before, and the one in the current row, because this is the row, right? To fill this entry in this row, I will use the values in the previous and current row to fill this. For this, I use previous column, previous and current row, to fill the current column row. Similarly here. So if I move here, for this entry, I use the previous column, right? And the previous and the current rows to compute the value in this row. Similarly for this previous column, the current row and the previous row. Obviously, you start by the previous because the previous will give you the more accurate. Because here you have age, because remember that in this row, we start, for instance, with age. Here, we start with a certain age, and now here, you have age by 2. Here you have age by 2 square, because you divide by 2 again. That's age by 4 or by 2 square. And here, age by 2 cubed. And if it continues, you will still increase the power of 2, or you divide by 2 each time. So you see that if I am in this current row, the more accurate will be the previous row minus the less accurate, which is the current row. And that's what we have here in the formula. You see, more accurate and then more minus less accurate. And as I indicated the other day, this n is order of accuracy. So it's such that you have big O of h by n. And we know that for the trapezoidal rule, n is 2. So this n is not the same n as the number of subdivision. No, it's not. I think I already mentioned this. It's in fact in the other setting where we call that alpha. Alpha, which is the, so I would write here n is alpha. The order of accuracy for the trapezoidal rule is 2. So that's why we divide by 3, because 2 squared is 4 minus 1, 3. So that's why in the formula here you will be getting in the denominator, then it will be 3. Here, this one, this 3. So this is what I asked you to check last time. Okay, now today we are proceeding with something new. And that's something new. You can see here we call it recursive trapezoidal. So you need to know the trapezoidal formula. And particularly this. You can see that this is the, you can see T here with this is, what is this? This is the composite. Composite. So meaning that here, each time what are you going to perform? You'll be performing something of this form. Because as your value of n will increase, you see that here we have 3 evaluation of the function. We move from 3 to 5, and so far you'll be increasing each time. So the knowledge of this composite trapezoidal rule is important because you'll be applying it here. Okay, now we're talking about recursive. This is very important. Recursive trapezoidal rule or formula. For what? Here we are taking equally spaced. Subinterval equally spaced. Okay. So what are we trying to do here? What we are going to do, we are going to use the composite trapezoidal rule, which is similar to what we have done here. And we are going to partition our interval into 2 to the n, sub-interval. No longer n, but 2 to the n. So we are taking a power of n. That will be our number of sub-intervals. It's no longer n. The number of sub-intervals is a power of n. And then we are going to define, because we are going to use a recursion, so we are going to define Rn, comma 0. So you see that when the second index here is 0, you have a trapezoidal row. So this indicates the first column, like in this table. Remember that this first column is a trapezoidal row. So we are going to generate a similar table, but we'll proceed as we have just described. We'll take the number of subdivision to be a power of n. Rn, comma 0, the second index represents the column. So 0 represents this one, the first one, which is the trapezoidal or the composite trapezoidal rule. So it will be similar to this one. That's why I asked you to take time and try to understand how this is generated. If you did it, fine. If you didn't do it, up to you. Good. So let me write here. So when we say R, it's like IJ. Where this I stand for the row number and J stand for the column number, where the column starts from 0. That is row number and J is the column number. Of course, I and J, in our case, it will start from 0. So when we fix J equal to 0, that's trapezoidal row. So when J is 0, which indicates the first column, we have composite trapezoidal row or formula. Okay, so that's what we have here. And then you can see that we are actually using it. You can see that we are using the composite trapezoidal rule here. All right? And even the summation, you can see that this is our 2 to the n is the number of subdivision, right? Minus 1. Remember that if you are using n subdivision, we will sum from 1 to n minus 1. But because our n number of subdivision is 2 to the n, then we take 2 to the n minus 1. Why? Because k equal to 0 is this one, and k equal to n, that is the total number of subdivision, is b. So they are already grouped here. Okay, let me scroll up to connect with what you already know, so that it will not appear to be something strange. You can see here. Okay, not this one, because this is a Simpson. Okay, we are here. You can see that this is our composite trapezoidal rule. This one. You can see that k runs from 1 to the number of subdivision, which is n here. It is that number minus 1, as you can see here. So we just substitute that value there. So it's exactly this rule that we are using, and that's our composite trapezoidal rule. Okay, so that's what we are doing here. Good. Now, this is where the recursion comes from. For a given, so this is the formula, but now we are going to generate a recursion here in recursion on n. Instead of using this all the time, what we can do, we assume that R, that is the previous. If I'm in the first column, which is this one, first column, the column of the trapezoidal, if I know the formula in the previous row, right? I want to compute the current entry of the row in the first column, knowing the previous one. Right? That's the recursion. So if I want to compute the entry of the current row in terms of the knowledge that I have from the previous row, this is what we get. So for the current row, I will use 1/2 the previous row plus this formula. Now you can see that it is similar to this one, right? But now this part is replaced by what? Is replaced by this. Now, where you see where R00, you see R00 is given by this formula. And actually, R00 is the very first value, which is in fact this. If you look at this, it is similar to this. Because actually, remember that for our trapezoidal rule, we have one subinterval in the beginning. We have one subinterval. So meaning that our h is b minus a. And that's exactly what you have here. So R00 is given by this. And then as you proceed, h will be changing. H will be changing. So this h is not fixed. H will be, so originally h is b minus a. But as you proceed each time, because don't forget that the number of subdivision here will be changing. Because see, you have n here. This n is that same n. Now, as you proceed, you see that n will be changing all the time. So as you proceed, this h will not be the same as the previous h. It will be changing all the time. H will be changing. And that is exactly similar to what we have here. You see that this h is no longer the same as the previous h. The previous h, you can see that the previous h here, this was 0.65, but now h is 0.3. So you have it each time. Each time you have. That's exactly what is happening here. So we are actually following something similar to this one. We have our h each time. So that's exactly what we are doing here. We take it as a power of that because we are halving h of the, we are halving. So that's exactly what is happening here. 2 to the n, next time I increase n by 1, so I'm halving. So you have to bear this in mind, otherwise the formula will look strange to you. That's what I'm taking this time to explain so that you don't get confused. I don't really need to rush here because if you miss this part, it will be difficult for you. And this always comes during the second test, test 2. This is like I'm giving you what is not a secret. I'm not hiding. I'm telling you what will come. I told you that Pade will always come, and it came. I'm telling you already that this recursive trapezoidal rule always come. So you will not discover it that day. So you are already informed that it will come. So it will not be a surprise. So that you will not say that it is witchcraft. Here we don't practice witchcraft. Here what we do is science. All right. All right. So explain again and again. All right, good. Again. I repeat. This h is changing all the time. Recursive, I will take n equal to, we start with n equal to 0, then n equal to 1, n equal to 2. Each time, h is changing. So meaning that the number of function evaluation that you get here will increase exactly the way you can see here. First time, we have 3 function evaluation, then 5. If we were to proceed, you have more, right? More and more. So it's exactly the same thing. So there's nothing new here. It mimics simply what we have been doing here. But now we write it in a recursive way, in such a way that you don't struggle that much. You use the previous computation, meaning that if your first computation is wrong, the rest will be wrong. So that's why you have to be meticulous. You have to take your time to understand and to do it properly, not to rush. Understand, do it. All right. Now, what I will do now, for you to really grasp this, I will take an example from the tutorial. And we are going to do it now, tutorial. We are going to see how to apply this. And in the tutorial, I will give you an equivalent formula, which is in fact more elaborated, if I can say, if I can call it like that. A more elaborated formula that is similar to this one. And that is the formula I will advise you to use in the test. Because that one, because there, okay, let's look at that. Let us look at that. Let me open that tutorial. And the rest of the time, we'll be solving that question. Okay, let me check. Yeah? Let me check. Ooh, troublemakers there. Oh.
Doctor.
Hello.
Yes, how are you, sir?
I'm fine, thanks, and you?
I'm good. I joined late, but I have a question. Let me take you back a bit at an example of Romberg.
Romberg.
Yeah.
Okay.
That
Okay. Let me tutorial one. Romberg. I hope you are not there to fight, ne?
Sorry?
It's fine. You say Romberg?
Yes. Romberg in the integration. That's the example there.
Yes, I'm trying to get there.
Hello, welcome to dinner.
Romberg. Wait, this one?
Yes.
Yes.
The thing that I don't understand there is the integral from, because if I checked h over 2, check, move a bit. Yeah. If I check the formula, the first formula and the second one, the long one, there is 0.65 over 2, then the bracket of e to power negative 0.2 squared plus 2 e power negative 0.852. If I compare that one with the second one, why we are having the different numbers there at 2, like plus 2 e to to power negative 0.525 and 2 times e to power negative 0.852 squared, I mean.
This one?
The other one, go back.
Here?
Yeah, that one and the other one, the second formula.
Okay, there are two different formulas. See, here we have h, right?
Yes.
H is 0.65, this one.
Yes, that one I understand. Because,
Okay, now here, h is no longer 0.65, but it's 0.325.
Yes, that one I understand. The part that I understand.
Okay, now you agree with me that if I have different h, it will give me different number of points in the interval. The number of points will double, isn't it?
Yes.
I mean, the number of sub-interval will double. Because here we have, the previous one is 2 subintervals, now we have 4 subintervals. 4 subintervals means that there are a total of 5 points. 1, 2, 3, 4, 5. Are we together?
Yes.
Here, because we have 2 subintervals, there are 3 points. 2. Look, if I take this AB, I divide into 2. How many points? 1, 2, 3. So this is A plus B by 2. So I have 1, 2, 3. 1, 2, 3. But now here, because there are 4, it will be 5. And these are the points. That is H, A, the first one. Each time you add H, A plus H. And if I add H to this one, it becomes H plus 2H. If I add H, it becomes 3H. If I add another H, it gives me the final one, which is 3.
Okay, I got it.
Any other question?
No.
Are you happy?
Yes, I'm happy, doctor.
So over the weekend, you are going to eat mahangu enough, right? A lot of mahangu.
Plus chicken.
Bambo chicken, of course. You have to mention bambo. Okay. Okay. What I will do now, I mentioned the tutorial. Huh? You have to do that. So that you'll be happy. All of you are going to eat bambo chicken over the weekend. I'm sure if all of you eat, you will come with a big one for me. All right. All right. Tutorial. Let us now move to the tutorial. Aaron Fred, I hope you are smiling because you understood those things. You can smile. See, when you understand math, you are so happy that you can eat a whole pot of mahangu. Okay, tutorial. Okay, tutorial 2. This is tutorial 2. Let me download it. Let me download it. It's here. Oh, okay, it's there. Let me see how to tutorial. Okay, download. Downloaded. Great. Okay, tutorial 2. Let me open for you guys. Tutorial 2 is there. Can you see what I see? Can you see what I see? If you don't see, you need to buy spectacles. Do you see, man? Do you see what I see? Hey, you guys, do you see what I see? Hey, you guys, do you see what I see? Guys, do you see what I see?
Yes, we do.
All right, that's great. Now, if you look at what is here, you see that it's not different from what was in the previous slide. I mean, in the note. Because this is what we call our R00. Remember, we said that R00 is this one, the initial, right? So T, in fact, I remember I told you, let me write it here, so that things will not, okay, so what we call T here, T whatsoever, TJ or T something, TJ, is exactly R J, comma 0. Remember that when this column number is 0, it's trapezoidal. That's exactly what we have. And we substitute J, in fact, whatever variable is there, huh? We call it N is J. And I told you that that varies. Remember that we wrote 2 to the N. Here, our H is 2 to the N. But if N is J, it's 2 to the J. And remember when J is 0, this is H by 2. So if you put 0 here, let me write, when J is 0, H, which is B minus A by 2 to the J, is just B minus A. So that's why we have B minus A here by 2. So this is your R00, which we call T0. This is R00. So if you put 0 here, it gives you T0. which is exactly what we saw in the note, which is b minus a by 2 into this. So h, in fact, is b minus a. And you see that for each h, for each value of j, h will be half each time. So h changes all the time. So h here is a function of j. It changes. So I can write here h subject to indicate that it changes, right? Okay. Now, n, this n, which is a number of what is that n? Number of subintervals. Am I right? No, not the number. Half the number of subinterval you can see here. You see? Look at this. Because n, this is n, the number of subinterval, right? Now, this will be capital N from here. You see that if you solve this, oh, it gives you that n is 2 to the j minus 1. Like this. 2 to the j minus 1. So here it is, you sum to half the number of subinterval, which is this. 2 to the j minus 1. 2 to the j minus 1. Right. Okay, now here you can see that what we have written here, we are taking, you can see that this is odd, right? 2k minus 1 is odd. We take odd subscript, and that is true for all values of j. We will be taking odd subscript. We are not taking all this x sub something, but we take odd, right here. Odd subscript. Okay, so this is like our r here. If you look at this one, it's like rn minus 1 here, or rj minus 1. So if you put j minus 1, it will give you t j minus 1 by 2. So it's similar to the other formula. But this one is more convenient. Yeah? So I'd advise you for the exam or test or whatsoever to use this one, this approach, this formula. Are we together? That is my advice. Are we together?
Yes, sir.
Good. Okay, now let us see how this is being done, how to apply. Okay, which example are we going to use? Okay, so here we are asked to compute T0, T1. Okay, so we are only performing the recursive trapezoidal rule. So we are computing all the Tj. Now, if you recall what we did in the tutorial, each time what we did, we took this h, we half it, and then this number, the number of function evaluation was changed, right? And then we substituted and we computed. So that's how we obtained the first column, the value in the first column. That is exactly the same thing we are doing here, but we are using a more simplified formula. We are using this formula. Okay, so let us do this. In this particular example, what are we doing? Use the sequential trapezoidal rule to compute T0, T1, T2, T3. So this is what we are doing. And we are given the exact integral, which is ln 5. Ln 5 is approximately this. It can guide us to check if our computations are going the right direction, right? Now, when you look at this, what is the value of your function f? This is the function you're integrating. Just by looking at this one, you'll be able to extract all the relevant information that we'll be using in the formula. So what do we need to compute for the formula? We need to find h, right? In H, what do we need? We need B and we need A. And we also need to compute this point, the uniform distribution point. We need this. We need to get, in anyway, n, we know that n is 2 to the j minus 1, so that's not a problem. And h is this. So actually what we need is, we need B, we need A, and we need F. Are we together? So what we need, what we need to know are these. We need to know A, B, F. What else do we need to know? Because for capital N, what is this one? It will be changing. Eh? Once we know this, this is our formula for H. It will be changing. It's changing all the time. Right. And N also, if it's changing also, this N depends on J. So these two depend on J. So H, N depends on J. So actually what we need from the onset is these three, 1, 2, 3. Now, if you look at this, what is A, what is B, what is F? What is A? Quickly, please tell me fast. What is A? I'm listening. What is A? What is B?
5.
And what is f of x?
One over x.
Good. Very good. Because if you cannot see this, it's finished. You cannot proceed. You need to identify. Because in general, this will not be given, right? It's there, but it will not be told explicitly there. This is A, this is B, this is, it's up to you to see it, right? If it's not given, you have to. Good. So that is it. Once you have it, the rest is just substitution. So now for t equal to for j equal to 0. Okay. Now what I will do, I will toggle to a new slide, right? So that I will not be writing on this. Right, I will open a new slide. We'll copy all this to that slide, and we'll start with our computation. So we start with T0, T1, T2, T3. Okay, let's make sure that we are right track. So the function, obviously the formula, we have the formula and everything. Remember this formula, write it somewhere. Write this. Anyway, you have the tutorial. So what I need to know now is this. All right, we know already that A is 1, B is 5, and F is this. So now let me let me move to a different slide. Good. Let me move to a different slide, and then we are going to. Trapezoidal rule. trapezoidal, 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 trapezoidal. Anyway, zoidal. Okay, so the formula, let us quickly write the. Is it really necessary? Okay, so we say that h b minus a by 2 to the j, right? Where j will vary up to where we want, right? And we also say that n, it is 2 to the j minus 1, right? Because this is the n that we will get in our formula. So T0, which is our R00, it is h, which is b minus a, by 2, because here 0. If you put 0 there, it's b minus a. Then f of a plus f of b. So this one is so easy that anybody can close his eyes and compute that one. Now Tj, this is a recursive formula now. This is our recursive formula. So this, in terms of the previous, which is Tj minus 1. So meaning that the previous computation will be used. Whereas before we use the composite trapezoidal rule, we will forget about what we computed previously. We will compute everything from scratch. But here you use the previous computation you have, and you add the extra, this one. Now here we have our h, and then we have the sum here, sum over what? K. So we take k from 1 to capital N, which is this one, to j minus 1. You see that this capital N is changing. Okay, instead of putting capital N there, let me just put j minus 1. And then f of what? Then we put 2k minus 1. That is, we take the odd subscript here. Obviously, we need to know what is x sub k or x sub I or whatsoever. So since we are using equally spaced, so we know that our x sub something, let's say sub k if you want, will be the first point, which is a, plus what? K times h, where h is this step size. That is it. So that's all we need. So we say that what we are integrating, our a is 1. We said that b was what? 6, eh? And then f of x is 1 by x. So with this, what do we need? We want to compute t.
B is 5.
Sorry?
B
Oh,
is
5. That's good. It shows that you pay attention. The other people, they think about their mahango. They even forget. Okay, so we want to compute this for j up to 3, right? Okay, it's up to 3. Yeah? In our case, we want to compute t 0, 1 to 3. I think we stop at 3. Now for j equal to 0, so we start directly. J equal to 0. So our t0, what is it? We can substitute directly here. It will be 4 by 2, which is 2, into 1 by 1 plus b, 1 by 4. 5. 1 by 5. Are we together? Are we together?
Yes, sir.
Good. Now, what is this? What is this? So this is 6 times 2, that is 12 by 5. All right. So 12 by 5, what is it? It's approximately 2 point something. 2 point what?
2.4.
2. 0.4. Okay, so that is so that's our T0 now. J equal to 1. Okay, for J equal to 1, what is N? Remember, we need to find N here. This one, N. So what is our capital N? J is equal to 1, so it will be 2, right? Are we together?
Yes, sir. Yes, sir.
No, it's wrong. It's 1. N is 1.
It's 1, sir.
Right? N is 1. J is 1. You put 1 here. Minus 1, 0. 2 to the 0 is 1. Right. And what is H? Now we divide by what? We divide by 2. Because J is 1, right? This is H. J is 1, so we divide 4 by 2, which is 2, right? Are we together? H is 2, isn't it? This is the formula we are using. We are using this formula, this one. Because we know already T0, so we will substitute. This is what we are using. Let me put it that way. So we know for this one, we use T0, which we have just computed. We need H. We need to compute H. This is our N, which is 1. We know it already. Now that. Are we together? Do we all agree that H is 2? This is the formula. P is 5. 5 minus 1 is 4. So here is 4. 2 to the 1 is 2. 4 by 2 is 2. All right. Are we together? I want to hear you. I want to hear you saying something.
Yes, sir.
Are we together?
Yes, sir, we are together.
Good. Okay, good. Now, how many points do we have? Anyway, that's not even a problem. We know the formula for x sub k here. But now in the formula, because this is our capital N is 1. So if we sum k from 1 to 1, it means that k takes only one value, which is 1. So we evaluate the function at only 1 point. So k is 1. If you substitute 1 here, what do you get? X1. So we only compute X1. All right. And what is our X1? Because that's the only thing we will compute. So what is our X1? It is A, which is this one. A is 1 plus K. K is 1, right? K is 1 into H, and H is 2. All right. So that will be what? 3. It will be 1 plus 2, which is 3. Do we all agree that X sub 1 is 3? A is 1, H is 2. K is 1. 1 times 2, 2. 2 plus 1, 3. And that is it. We are done. So we substitute that in the formula. So this implies that our T1 is T0 by 2. And we know T0, which is 2.4, right? Plus H into F. So that is 1.2. If I want, I can divide this directly, which is 1.2 into H is 2 times F of 1. So 1 by 3. Is that clear for everybody? Now, if I multiply this by 3, this will be 3.6, right? 3.6 plus 2. That will be 5.6 by 3. So what is 5.6 by 3? 5.6 by 3 is 1 point what? 1.8666, right? Okay, let me stop after 4. Then the last will be 7. I can round up. So this is what we get. Are we together? Is that what you obtain? Okay, now for the next one, check, there might be mistakes, so make sure that you check. Don't just swallow everything that we say here. You have learned, you have a background for you to check. There might be errors. You have to always check. Okay. Okay, so now what is our N? So J is 2. J minus 1 is 1. So what is N? N is 2. Are we together? Remember that capital N is 2 to the J minus 1. J minus 1 is 1. 2 to the 1 is 2. And what is our H? H will be half, right? You take the previous and you half. Right? Remember that we are halving H each time. So for 0, remember that for 0, H is 4. Then if you have 4, we have 2, we half it again, we have 1. Right? So each time we just half. For H, we just half each time. Next time it will be 1 half. Okay, now. And what is our capital? Okay, we say capital N is 2. So K will take 2 values. K will take the value of 1, K will take the value of 2. So meaning that we will compute how many Ks, X. We have X1 and X3. Remember that we are taking odd subscript. So it will be, but this X1 is no longer the same as this because of what? Because of our H. H is changing. Previously, H was 2, and now it is this. So our X1 and X3 will not be the same. So let me just write the value here. So what is X1? When K is equal to 1, you have X1. That's K is 1, right? So X1 will be X0, that is A, and A is 1. It will be 1 plus H, which is 2. Remember that previously it was 3, but now it's 2. Okay. Now we move from 1 to 3. That is, we take 2 steps. Right? So the next will be what? 4, isn't it? It will be 4. Are we together? Okay, let's check. Is x3 equal to 4? Let me write it here and let's check. Because a step is 1. If I take 2 steps, that is I add 2 from what? From the original, which is 2. So if from 2 I add 2 steps, that would be 4. Okay, let's check. That x3 is 4. All right, so let's go back to the formula. This is our formula. We said that k is 2 now, right? Because to get this 3, if I put 2 here, 2 times 2 is 4. 4 minus 1 is 3. So k is what? 2. Now I take 2, substitute here. 2 times 1 is 2. H is what? 1. A is 1. So if A is 1, yeah? Yeah. I take 3. No, I take 2. This is 2. K is 2. H is 1. So 2 times 1 is 2. And 2 plus A is what? A is 1. Oh, it's 1. Okay. So A is 1. So it will be 3 instead, right? It will be 3 because we start from 1. So 1 and I add 2 to 1 is 3. Okay, so go to check. Yeah? It's 3, not 4. Okay, is that okay now? Is everything clear? X0, which is this one, X0 is 1. Right? And then from X0, we use 3 steps, in fact. K is 3. 3, no, it's 4. Oh, what did I do wrong here? It's 4. Because K is what? Oh, no, K, yeah. The subscript is 3. I put 3 here. 3 times 1 is 3, and 3 plus 1 is 4. I was right the first time. So it's 4. All right, it's 4, not 3. Sorry for the confusion. So it's 4. You just substitute this value. K is 3. 3 times 1, 3 plus 1, 4. It's correct. Okay, so what else do we need? We only need those 2 points, so we quickly substitute. So this implies that T2. So what is T2? Is T1 by 2 into H. Then we have F x1 plus F x3. Right? So this is, anyway, you will do the substitution. I will not do that. And similarly, let's do the J equal to 3, the last one. So what will be the value of N when J is equal to 3? It will be 4, right? N is 4, isn't it? N is 4. Here, we take 3 minus 1, 2. 2 squared is 4. So we are here. And now what is the value of H? We have. So H will be 1/2, which is 0.5. 0.5. That is our H. And then we need to find the point. So how many points are we using here? So we are going to use 4 points in total. Previously it was 2 points, but now we have a total of 4 points, right? So we have all the odd values, right? We have x1. So what is x1? X1, we start from 1. We start from x0, which is 1. We add a step, which is 0.5. So that would be 1.5. The next one is x3, right? Then what is x3? Remember the value of xk is a, which is 1 plus kh. And our h is what? 0.5, which is divided by 2. Right. Now, if we take 3 here, we put 3 here, that would be 5 by 2. right? This is 5 by 2. And what is 5 by 2? 2.5. Are we together? So this is for x. Okay, now each time we will be taking 2 steps, right? Because if I add 2 steps here, 2 steps, right? 2 steps, if I take 2 steps from this one is 1. So if I add 1 to this is 2. I add another 1, it will be 3. So x 5 will be 3.5. That is 1, 2, 3. And the last step, x 7 is 4.5. Okay, so these are the points. And we just substitute in our formula. So we have 4 points. The first one, 1, 2, 3, 4. So, and finally, you substitute this and do the computation. I'm just writing the formula for you. So it will be the value we get here, T2, that you divide by 2, plus h, and our h here, we saw that is 0.5. 0.5 into f of all this. So the first one will be f of 1.5, which is 1 by 1.5, plus 1 over 2.5, plus 1 over 3.5, and finally plus 1 over 4.5. So you can do the computation for yourself. It will be this value, which we can also quickly compute here, right? Okay, let me give you the value for this one. You can quickly also do that. So for this one, this is T0, T1 by 2, which is 1.8667 divided by 2, plus h, which is 1, so it will just be 1 into x1, that is 1 by 2, right? Plus this, which is 1 by 4. So you can just compute this, right? This is easy to compute, so you can use your calculator and quickly compute that value, and then you take that value. So what is the value you get? So the value that you get here, you put it here, you divide by 2, plus, then you take this 0.5 into, now this is 1 by 1.5 plus 1 by 2.5 plus 1 by 3.5 plus 1 by 4.5. And then you have all the values. And that is it. So now, can you tell me what you got from this first computation?
Sir, I got 1.683.
You got what?
1.683.
63 only.
683.
683.
3.5, sir. Okay.
3.5.
No. Sir, between the 3 and the 5, there's another 3.
Oh, 335.
Yes.
Okay, let's check. 0.5 plus 0.25 plus 1.8667 by 2 equal 168,335. Good. Now you take that value, you half it, and then so that is 1.68335. So you can do the computation yourself. Now, if we compare this value of T2 with the one given to us, where is that? what is that tutorial 2? The value that was given to us was 1.609. 1.609. You see that we are getting close to that. You have already the 6, and then we need 0.9. So by proceeding, we will get closer to that. So this is already good. But the first one, you see that the first one, which is 2.4, is still far. But now when we take T, no, even here already, T1, you can see that T1 is not far also from there, because we are already at 1.8, even though it's not 6, it's already 1 point. But this one, the first one, T0, is too far. But now when you compute T1, it's 1.6, 1.86. Now when we proceed, we have 1.6. Now you see that the 6 is already changed, the 8 is changing to 6. But the next one is 8 instead of 0.6 or 0.9. So as we will proceed with the computation, you see that these digits will get more and more accurate. So that's our trapezoidal rule. So we'll stop here. Please do this computation. Who computed this already? Have you tried to compute the T3?
I got 1.62897.
0.89?
6587.
76. So this can be okay. Okay, let's round this one to 7. So it's approximately that. Now you can see that this 2 is getting closer to 0 because here you have 8, right? In the third position, this one is 8. Now you see that this 8 is dropping to 2 because it has to get closer to 0. So you see that it's converging. Okay, thank you so much. I hope you understood the procedure. The most important thing here for you, the take home at this stage, is to understand how to use this recursive formula. The first thing to notice is that this h will be changing and the number of points that will be evaluating will be changing also. And each time we will need a previous value that will be halving each time, and we'll be adding this extra term. Okay, thank you for your kind attention. Have happy maths weekend, and take time to also eat mango nicely so that you will be strong enough to face next week. God bless you and see you next time. Bye-bye.